In the 1930s New York, men dangled from wooden planks 800 feet above Fifth Avenue, wrestling sheets of glass that weighed more than 2 grown men. A single pane for the Empire State Building's upper floors tipped the scales at 300 pounds, yet the crews hoisting them worked without harnesses, nets, or any equipment we'd recognize as safety gear today. One slip meant a fall through thin air with nothing to break it but the pavement below. These weren't daredevils seeking thrills, they were window installers, craftsmen whose job demanded they handle fragile, expensive glass in conditions that would paralyze most people with fear. Why did they accept such staggering risk? And how did an entire industry operate this way, one pane at a time, without modern protection? The answer reveals not just courage, but a system where speed, skill, and economics collided at deadly heights. The skyscraper boom of the late 1920s and early 1930s transformed American cities into forests of steel and glass. The Empire State Building, completed in 1931, demanded more than 6,500 windows. The Chrysler Building, finished just a year earlier, required thousands more. Each tower represented a new challenge, how to seal buildings against wind and weather while letting in light through enormous expanses of glass. Window installation became its own specialized trade, distinct from the ironworkers who assembled the frames or the masons who laid brick facades. These glaziers worked on a precise timeline, moving floor by floor as the steel skeleton rose. Developers pushed for speed. Every day of delay meant lost rental income. Insurance companies demanded weather-tight buildings before winter storms arrived. The pressure funneled down to the men on the planks who had to measure, lift, and set glass with absolute precision while suspended in midair. The glass itself was revolutionary for its time. Plate glass manufacturing had advanced dramatically since the early 1900s, when most window panes were small and relatively light. By 1930, factories could produce sheets measuring 8 feet tall and 5 feet wide, smooth enough to eliminate distortion and thick enough to withstand wind pressure at extreme heights. The grinding and polishing method produced these massive panes. Molten glass was poured onto large tables, allowed to cool, then ground flat with progressively finer abrasives before final polishing. This process created optically clear glass free from the waves and distortions common in earlier window panes. The factories that supplied New York's building boom operated around the clock, processing sheets that would eventually hang hundreds of feet above city streets. But size came with weight. A standard office window pane ranged between 250 and 350 pounds, depending on thickness and dimensions. Some specialty panes for lobby windows exceeded 500 pounds. Transport from factory to construction site was its own challenge. Glass couldn't simply be stacked like lumber or bundled like steel beams. Each sheet arrived by truck from Pennsylvania or West Virginia, carefully crated in wooden frames built to precise dimensions and packed with sawdust and straw to cushion against road vibration. A single hard jolt could crack multiple panes, turning a profitable delivery into a total loss. Trucks carrying glass moved slowly, avoiding rough roads and sudden stops. At the construction site, storage demanded equal care. Rain could seep into crates and cause spotting, freezing temperatures could crack panes through expansion of trapped moisture, and direct sunlight could overheat glass stored in tight packing. Large projects required dedicated ground floor storage spaces where glass could be kept dry and accessible for hoisting. Workers uncrated each sheet on site, inspecting for cracks or flaws that could cause it to shatter under stress. A single damaged pane discovered after installation could mean dismantling scaffolding and repeating hours of work. Moving these massive sheets required coordination between ground crews, hoist operators, and the glaziers themselves. Hoists lifted the glass from street to working floor, threading between steel beams and temporary construction platforms. Unlike steel beams, which could be dropped a few inches without catastrophic damage, these massive panes demanded gentleness at every stage. The panes rode in wooden cradles with padded edges designed to cushion them against sudden movements. Hoist operators, using the same steam-powered derricks that lifted steel, learned to start and stop gradually, avoiding the sudden jerks acceptable when moving iron. Signalmen directed each lift with hand gestures, but with even less margin for error. A swinging load could crack a pane worth several weeks of a worker's wages. At the installation floor, the real challenge began. Glaziers worked from wooden planks suspended by ropes or cables, positioned just outside the building's frame. These planks, called scaffolds, measured roughly 2 feet wide and extended 12 to 16 feet in length. Multiple planks would be lashed together to create a working platform along an entire floor's perimeter. The scaffold hung from the steel frame above, secured by rope loops tied around beams or hooked to temporary anchor points. There were no guardrails, no toe boards to prevent tools from rolling off, and no safety lines connecting workers to anything solid. The scaffold system evolved as buildings grew taller and construction companies learned from accidents. Early scaffolds were simply wooden planks roped to whatever anchor point was convenient. By 1930, some contractors used wire cable instead of hemp rope, improving strength and reliability. Metal brackets bolted to the building's frame provided more secure anchor points than rope loops, though installation still depended on the skill and judgment of the rigging crew. Despite these improvements, the scaffolds remained fundamentally temporary structures with minimal engineering. There were no load calculations, no inspection requirements, and no standards for how much weight a given setup could safely hold. A typical scaffold might support 3 workers, their tools, and a massive pane, easily exceeding half a ton of total load. The anchor points had to hold all this weight, plus the dynamic forces of men moving around and wind pushing against the structure. 2 or 3 glaziers typically worked together on each section, with one man acting as the lead installer and the others assisting with positioning and securing the glass. They wore leather gloves to protect their hands from sharp edges, but the gloves had to be thin enough to maintain grip and feel. Heavy winter gloves were too clumsy for the fine adjustments needed to seat a pane properly in its frame. Canvas aprons protected clothing and provided pockets for tools, such as putty knives, glazing points, and small hammers, but offered no protection in a fall. The technique for lifting and setting a pane was part strength, part leverage, and part timing. The glass arrived at the scaffold's edge in its wooden cradle, positioned by the hoist crew. The glaziers would grip the sheet by its edges using suction cups in some cases for the largest panes. These cups, made of leather or rubber with hand pumps to create vacuum, gave the men something to hold beyond just the glass edge itself. But suction cups could fail if the glass was wet, dirty, or if the seal broke under strain. Working together, the crew would tilt the pane upright, pivoting it on one edge while supporting it from multiple points. The lead glazier positioned himself at what would become the top of the window once installed, while his partners steadied the bottom and sides. They moved in unison, walking the glass across the scaffold toward the window opening. Every step had to be coordinated. One man moving too quickly or losing his grip could send the pane crashing down, or worse, toppling sideways and taking the whole crew with it off the plank. Once positioned at the window opening, the real test of skill began. The steel frame around each window had been set with precise measurements, but construction tolerances meant that every opening was slightly different. The glaziers had to ease the heavy sheet into the frame's rabbets, the L-shaped grooves that would hold the glass, while checking for fit on all 4 sides. Too tight and the glass would bind or crack under pressure. Too loose and wind would whistle through gaps, or worse, the pane could work free and fall. The crew tilted the glass to slide the top edge in first, then carefully lowered it into place, checking alignment as they went. One man held the full weight at an angle while another tapped the bottom edge with a rubber mallet, adjusting position by fractions of an inch. A third worker might be reaching around the frame from inside the building, ready to place temporary wooden wedges to hold the glass once it's seated properly. The entire operation happened while balanced on a 2-foot-wide plank with nothing between the workers and a fatal drop. Wind was the constant enemy. At heights above 500 feet, gusts could reach 40 miles per hour on an otherwise calm day. A sudden blast could catch a pane being maneuvered into place, turning it into a sail that either shattered against the frame or pulled the workers off balance. Crews learned to read the wind, watching for telltale signs, flags whipping on nearby buildings, dust devils rising from the streets below, or the feel of pressure building before a gust hit. On particularly windy days, work stopped. Foremen made the call, weighing the cost of delays against the certainty of damaged glass and injured men. But the pressure to keep moving was intense. Contractors faced penalties for late completion, and those costs cascaded down to the workers in the form of reduced hours or outright layoffs. Some crews took chances they knew were foolish, gambling that they could set just one more pane before the weather turned worse. Once a pane was seated in its frame, the securing process began. Glazing points, small triangular pieces of metal, were driven into the wooden frame around the glass perimeter, holding it in place while glazing compound cured. The compound, a putty-like mixture of linseed oil and chalk, was worked into the gap between glass and frame with putty knives, creating a weather-tight seal. This finishing work required reaching around the glass from the outside, often while leaning far out over the plank to reach the frame's edges. Rigging failures killed workers regularly. A rope frayed by rubbing against a steel edge could part without warning. An anchor bolt over-torqued during installation might crack the steel beneath, creating a hidden weakness that gave way under load days later. Some failures were catastrophic, with entire scaffold sections dropping and taking everyone on them to their deaths. Others were near misses, planks tilting suddenly, dumping tools and materials while workers clung to ropes or grabbed for the building frame. The economics of window installation created pressure that overwhelmed caution. Glaziers were typically paid by the pane or by the day, with bonuses for crews that completed floors ahead of schedule. This piece rate system incentivized speed over safety. A crew that took time to double-check rigging or wait out marginal weather earned less than one willing to push through. The men who hesitated, who voiced concerns about conditions, often found themselves passed over for the most lucrative jobs. Insurance existed but barely covered the risks. Workers' compensation laws varied by state, and in many jurisdictions, death benefits for a fallen worker amounted to a few $1,000s at most, perhaps $3,000 to $5,000 in the 1930s currency, equivalent to roughly $50,000 to $85,000 today. For families left behind, this was a catastrophic shortfall, barely enough to cover funeral costs and a few months of lost income. The companies that employed these men carried liability insurance, but the premiums were calculated based on accident rates that everyone accepted as normal. Liability. The culture among glaziers mirrored that of ironworkers and steeplejacks, a complex mix of pride, fatalism, and dark humor. Men joked about their work being a pain in the glass, while acknowledging that every day could be their last. They developed superstitions and rituals, never starting a difficult installation on Friday the 13th, always checking equipment in the same order, refusing to work with anyone who seemed nervous or distracted. These informal rules created a sense of control in a fundamentally uncontrollable environment. Even when basic safety belts became available in the 1930s, most glaziers refused to wear them. The belts were heavy, uncomfortable, and restrictive, making the precise movements of window installation harder. The thick leather clamped down on the waist and pinched at the hips, interfering with the hip rotation and body positioning needed to maneuver heavy glass. The best glaziers, the ones who commanded top pay and led the most prestigious jobs, worked with apparent ease at deadly heights. They moved confidently, handled enormous panes with casual grace, and finished installations faster than crews who proceeded more cautiously. Their example set the standard that everyone else tried to match, regardless of their own comfort level with the risk. A man who needed a belt to keep him on the scaffold was a man who didn't belong there. Apprentices learned the trade through observation and experience, not formal training. A young man might start as a ground crew member, handling glass deliveries and watching the installation crews work from below. If he showed aptitude and courage, he'd be invited to try working on the scaffold, first on lower floors where a fall might only break bones rather than guarantee death. Those who proved themselves steady moved up to the high work, where pay was better and respect was earned through demonstrated skill. Falls were common enough that every crew had stories. A man's boot slipping on a wet plank, a sudden gust catching him off balance, a rope anchor giving way. These weren't rare events but accepted hazards of the trade. Some men survived falls through sheer luck, landing on lower scaffolds or catching a beam on the way down. Others weren't found until the end of the workday, their bodies discovered where they'd landed in alleys or on rooftops below. Newspapers reported the most dramatic accidents but ignored the routine deaths that happened out of public view. Despite all precautions, broken glass was a constant expense. Industry estimates suggested that 5 to 10% of all glass delivered to a major construction site would be damaged or destroyed before successful installation. Some broke during transport, some during hoisting, and some shattered when workers attempted to fit them into frames that had been measured incorrectly or had shifted as the building settled. The cost of these losses was built into project bids, but that didn't make them less frustrating for the crews who had to handle the same pain multiple times or deal with cleanup of shattered glass raining down from scaffolds. The human toll was harder to quantify, but impossible to ignore. While comprehensive statistics from the 1930s don't exist, construction death rates from that era paint a grim picture. Falls from height were the leading cause of death on construction sites, and window installation ranked among the most dangerous specialties. The informal calculation accepted by many contractors, one fatality per $1 million spent, reflected an industry that had normalized preventable deaths as simply the cost of building skyward. The transition towards safer practices began slowly in the late 1930s and accelerated after World War II. The development of lighter, stronger materials for rigging, steel cable, aluminum brackets, synthetic ropes made scaffolds more reliable. The introduction of motorized hoists with better control systems reduced accidents during lifting. But the biggest change was cultural, driven by union pressure and eventually by regulation. Workers began demanding better protection, and companies that resisted found themselves unable to recruit skilled crews. Unions pushed for basic protections throughout the 1940s and 1950s, winning incremental improvements in equipment and working conditions. But comprehensive federal oversight didn't arrive until 1971, when the Occupational Safety and Health Administration brought sweeping changes to construction sites nationwide. OSHA's standards required fall protection for any work above 6 feet, mandated inspections of rigging and scaffolding, and imposed penalties severe enough to change industry behavior fundamentally. Modern window installers work in conditions that would be unrecognizable to their 1930s predecessors. Powered scaffolds with guardrails eliminate the exposed wooden planks of earlier decades. Full-body harnesses with multiple attachment points replace the refused leather belts, designed with modern materials that move with the worker rather than restricting movement. Mechanical lifts and suction systems handle the heavy panes, reducing the need for manual wrestling of glass into position. The transformation represents one of the most dramatic safety improvements in any industry. Yet the fundamental challenge remains: installing fragile, expensive glass at dangerous heights while maintaining precision and speed. What's changed is the recognition that accepting routine deaths as the price of progress was never necessary, only convenient for those who prioritize schedules and budgets over human life. Each regulation, each piece of modern safety equipment, traces its origin to workers who died doing jobs that could have been made safer with existing technology and knowledge. The buildings themselves remain, their windows still catching light above the streets where men once risked everything to install them. The Empire State Building's facade, the Chrysler Building's gleaming crown, the countless other towers from that era, each pane of glass is a testament to skill and courage, but also to a system that accepted deadly risk as normal. Today's safety standards emerged from lessons written in those earlier workers' blood, each regulation a response to deaths that should have been prevented. The Glaziers who worked without nets or harnesses weren't heroes or fools. They were craftsmen doing what their industry demanded in an era that valued speed and economy over human life. Their legacy isn't just the skylines they created, but the reforms their sacrifices finally forced into being.